This is lesson 3-4, slope of linear relations graphically. In this lesson, you will learn how to understand various types of slope on a graph and how to determine the rate of change of a linear function on a graph. All right, let's take a few notes. Slope is used to describe the measurement of steepness of a straight line. Slope is also described as the rate of change. There are four types of slope. Positive. A positive slope are lines that go uphill, like you see this skier going uphill. I know we can't ski uphill, but that shows you a visual of that. Next type of slope would be negative. And this line goes downhill. When we talk about uphill and downhill, we're going from the left to the right. And so when you hit that here, you go up. From the left to the right, you hit this and you go down. Obviously, this skier isn't going to go anywhere because this is a zero slope. Lines that run horizontal have zero slope. And then we have, obviously, this skier here will fall down and become undefined. It's just a funny way of looking at it. Anyways, a vertical line is considered to have a undefined slope. We'll talk about why that is mathematically later. Okay, so slope just describes the steepness of a line, and there's a lot of different ways that we use to describe it. For instance, it's the difference of the y values over the difference of the x values, or we say the change in y over the change in x. Sometimes you'll see the Greek symbol delta for change in y over the change in x, or the vertical. Because remember, vertical is the y, so the change in our vertical over the change in our horizontal. And then this is the formula that we'll be using. Okay, the second y is what this means. It's y sub 2, but it means the second y minus the first y over the second x minus the first x. So we'll go ahead and we'll look at this line that's graphed. And what you do is you find two exact points along the line. Okay, and if they're marked with points already, then you don't have to worry about it. It looks like this line got a little off. But we'll just go with the marked points on the line. And what you're going to do is find the rise over the run. So you're going to count how many squares up you have to go from one point to another. And it doesn't matter which points you use, just choose two. So we're going to go 1, 2, 3. So that's our rise. So our rise was up 3 squares. And then our run is only over 1 square to get to that other point. So that's rise is 3, run is 1. So the slope of that line is 3. And notice it's a positive uphill line, so the slope will be positive. Okay, so we have some points here, and I'm going to show you a couple different things here. So one, I'm just going to use this set of points here. So we're going to go rise, 1, 2, 3. So it's 3 squares up and 1, 2 squares to the right. Remember, up is positive and right is positive. Rise over run. The biggest mistake people make is they mix up the numbers and they'll put the numbers in the wrong order. They might put 2 over 3 instead of 3 over 2. Okay, you can also do a slope triangle underneath. In this case, if you go underneath, you're going down 3, which is -3, and you're going left 2, which is -2, and -3 over -2 still equals a +3/2 because the negatives would cancel. I typically always make my slope triangles above the line because I'd rather not deal with very many negatives. Another thing that you'll notice is that I use 2 points that were consecutive, but what if you use 2 points that were not? So let's go ahead and we'll go from this point to this one. That would be a rise of 1, 2, 3, 4, 5, 6. And then our run is 1, 2, 3, 4. So that is 6/4, and that would reduce to 3/2. So we still have the same rate of change no matter what 2 points we use, but it's less counting if you use 2 that are closer together. So I'll typically choose 2 points that are closer to one another. So the slope of that line is 3/2. It's a puff positive line and it's going up. So our slope is positive. All right, the next example, again, we have points marked for us. It looks like a positive line. So we're going to go up 1. You stop at the point which you would hit this if you came across. Okay, so the run, because you're going to make a right triangle here. If you'll notice, all my triangles end up being right triangles. Our run is 1, 2, 3, 4. So rise over run is 1/4. Okay, 3/2, it really does equal 1.5. We're not going to change it to a decimal though, but I want to show you for comparison purposes. Notice 1.5 is bigger than 1/4, which is 0.25, and notice how much steeper the line is. So the greater the number, the steeper the line, okay? But in slope, it is okay, and it's actually the desirable way to list your slope is in improper form as a fraction. All right. Next, we have a negative line. I go, nice, negative line. So that means our slope is going to be negative. And that's going to make a slope triangle. Our rise is up 1, but this time we're going left. We're going left 1, 2, 3. Well, left is negative. Look, if you go on the number line to the left, it's negative. Rise over run is 1/3. I already put my negative on. I decided it ahead of time. I prefer to decide if my line is positive or negative just by looking at the direction of the line ahead of time. Then I don't have to think as deeply about if I'm going up, down, left, or right. Okay, we have a negative line here, so we know our slope is going to be negative. Now this one does not have points on it for us. It looks like we have one here. Okay, and that's it. So what we do is we go along the line until we find a spot along the line where your line crosses the corner of a square. And this is the first corner I come to. Notice it doesn't cross a corner here or here. There's another corner. And it doesn't matter. You don't need to have a whole bunch of them. I'm marking them all just for purposes of showing you. Okay, and you can go ahead and make a slope triangle. So our rise is 1, 2, 3. And our run is -1. So our slope is -3/1. And you don't have to write it as 3/1. You could just simply write 3, -3. All right, this slope, if you look at it, it has no rise. So the rise in this slope is 0. Okay. The run, let's say I make 2 points. I'll just make the run right next to it. So the run in this case is 1. If you go over 2, it'd be 0/2 or 0/3, etc. Well, 0 divided by 1 is 0. So the slope of this line is 0. And notice before, when we were just initially introducing this, we talked about this being a horizontal line having 0 slope. And I said I would show you mathematically. Boom, 0. Okay, here we have a vertical line. And if I were to calculate the rise over the run, notice it has, in this case, a rise of 1, but it has no run. So the run is 0. Well, if you go ahead and type in 1 divided by 0 in your calculator, you will get an error. Or sometimes they'll say domain error. Okay, and if you ask Siri what's 1 divided by 0, she has a lot of interesting replies, so you might want to try that on your own time. But we can't divide by 1 by 0, so we call that undefined. It's an undefined number. So anytime you have a vertical line, you will have an undefined slope. All right, that concludes the lesson on slope triangles and finding slope of a graph.